Welcome back. In this video I'll show you how to implement some screen space shaders and also show how they were used in the final painting. Start by adding a control node to your scene. Click the Layout drop-down and select Full Rect from the Anchor presets. That will make it full screen. Now create any UI node. I added a color rect, but any node should work. Make it full screen as well. Also create a new shader. In the canvas item panel, select material and add your shader as a new shader material. Define it as a canvas shader, add a sampler 2D to grab the scene behind it, sample the screen texture using the screen UV and assign it to the color variable. If you did everything right, then it should disappear as it is now rendering a copy of the background. Let's display only the red channel of the image as a first test. Run the scene. And there we have it. If you have the UV and the RGBA channels available, there is a lot you can do. If you sample the image with scaled UVs and assign one channel from each scaled and recentered image, you will have something that looks like chromatic aberration. You can make the effect more pronounced at the edges of the frame. To do that, you will need the distance from the center of the image. Remap the UV to range from -1 to 1, then calculate the length. If we assign the length value to the color variable, that's what we'll get. That's one way of making a vignette shader, which, by the way, can be adjusted by adding an offset to the distance to clear the middle of the image and using the power function to make the fall off more aggressive. You may color it or blend using different blend functions, but I'll use it to modulate the chromatic aberration. The vignette variable is inverted here because we want the effect stronger at the edges. Then we use the variables to scale and offset our red, green and blue UVs. Notice how the edges are a lot more pronounced now and the middle is kept quite clear. It's up to your creativity. Let's see some other fun examples before creating the paint effects. I'm defining a simple blur function here. It uses only 4 directions instead of 8 with the diagonals. The directions have the same weight, so it is just the average between pixels. See how the shiny sparkles look like diamonds now. That's because of the kernel shape and the UV offsets used. They are bigger than 1 pixel. If you want to grab the neighbor pixel, use screen pixel size as your SPS variable. See how each variable is an offset from the center pixel. This matrix, also called convolution kernel, can also be a 5x5 or even bigger matrix. Now you are looking at edge detection or Laplacian, sharpen, emboss. And there are many filters like this that use different kernels and weights. You can even create custom kernels. Have fun with them. Now let's distort our image a bit to mimic paintbrush strokes. Add a noise texture and a noise intensity uniform. Assign a value and a new noise texture and hit play. That's one of the tricks I used to make the final render more like a painting. I used a very small value though. Bear in mind that this effect is like a stained glass in front of your face. If you move the camera around, it will be disgusting to look at. In canvas items shaders, it's not possible to sample the depth texture, therefore you can't make nice effects like the depth blur. But Godot already provides that to us in the camera attributes. I'm saying that because there is an alternative to rendering post-processing shaders by simply using a quad right in front of the camera. I made a custom height fog shader for my game Sepulchrum using this technique. It can be incredibly useful as you can even recolor or retexture objects by projecting textures over them. So if you want this distorted effect in global space, you can use the depth texture to find the XYZ position of the pixel and distort the screen UV according to its depth and a 3D noise texture. The theory is the same used in the past video for the fake refraction shader, but let me know if you want to see it done in another video. Now I want to show you the partial derivatives. They tell us the difference between the current pixel and its neighbors. We can use them instead of the convolution kernels for more performance, as we skip sampling the texture multiple times per pixel. The effect this line creates by adding the derivatives is similar to an edge detection or a sharpen filter. Then I just mix in an additive way that creates a filter that accentuates the highlights. If you blur the highlights only and apply over the image, you will have something similar to bloom. That is done with another pass, generally downsampled to make it more performant. Canvasite and shaders, however, don't support multiple passes. You will need to get creative with viewport texture and multiple canvas elements. Luckily, Godot has a good enough bloom shader in the environment stack. Canvas shaders also don't support HDR, which is a great tool to write in bloom shaders. One more common use for partial derivatives is the outline effect. Invert them, constrict them, and use the final value to mix the background with a black color. Looks dirty because it outlines based on color and not on depth differences. That's another limitation to our canvas shaders. Now let's see our final shader. Screen distortion using a noise texture, kernel-based sharpen filter, partial derivatives edge highlighting, vignette and custom blending functions. I won't go into blending functions because they are too simple. They are just rules defining how two pixels should be mixed. Throughout the series, you've seen me adding, subtracting and multiplying colors. There are more elaborate functions out there. In fact, the possibilities are endless. So let's do our final touches by adding vegetation, pebbles, trees, particle clouds, more particle clouds, and showing you how the final scene looks once we go into FreeCam. As in many games, you can get away with literal pieces of paper representing your trees if they are far enough. Let's see the final shader. It uses noise-based UV distortion, vignette, partial derivatives highlight boost, kernel-based sharpen filter, and another noise texture overlaid to add a brush stroke like a texture. That's it. If you liked it, the best way to support me is just by sharing my game Sepulchrum. It really needs more exposure and feedback. Now take care, and I hope to see you in another video. Thank you for watching.